Can I stay after school?
Never. We'll see.
On Thursday and Friday.
Oh my gosh, if you stay after school next week, Thursday and Friday, I will let you in the cafeteria or library.
No, you didn't hear me. I mean after school ends, so I can get help on math.
That's fine, I'm here till 3:15 anyway.
Yeah,
sure.
Even on final day?
Sure.
So.
Okay, here we go. Last lesson of this unit that you're going to have a quiz over on Wednesday, then the whole unit test on Friday. Multiplying polynomial guided notes. Okay, the first section, it's just a refresher. You guys already know how to do this. It says, recall, when multiplying monomials with the blank base, you actually blank the exponents. What do you guys think goes in those blanks?
Blank.
So we're going to add the exponents when they have the, what kind of base? Same. Okay? So we've already done this type of problem. So we're looking at this. When I go to simplify this, or when I go to solve this, what do I do first?
Add.
Well, I'm going to multiply. So I'm first going to multiply my coefficients. Okay? So when I first multiply my coefficients, what does 3 times 5 equal?
15.
Okay. So I'm going to write my coefficient down. Then I'm going to look at my exponents. I'm going to find exponents with the same base. And I'm going to put them in alphabetical order. Here they're kind of flipped, and that's okay. What comes first, H or K?
H.
H. Now I have the same base and the same base. If I have the same base, I, according to my notes, say add the exponents. So when I add my exponents together, what am I going to get?
3.
H to the 3rd power. And what about my K's? What's my K's going to be, guys? Same exponents. They're the same bases. Which equals?
17.
Wait, what's 14 plus 2? Or, excuse me, 14 plus 3, you are right. 17.
I was about to say because 4 plus 3.
Yeah, you're right. So, you should know how to do this first part. Okay? Now, I'm going to tell you, on today's lesson, you already have all the skills that you need in order to complete it. You know how to distribute. You know how to combine like terms. You know how to multiply exponents. Okay? We're just going to make it a few extra steps. Okay? Me too. Okay, so this first one is called a monomial times a polynomial. Okay? So when you're taking a monomial and multiplying it by a polynomial, the only step you're going to have to do is distribute the monomial to everything inside the parentheses. So that means I'm going to take this 5x and I'm going to distribute it to everything inside the parentheses. Do you guys know how to distribute?
Yeah.
You know how to do this. What's the only twist?
That's the exponent.
Yeah, the exponents. Okay, so I'm going to take this 5x and I'm going to follow what my notes say and I'm going to distribute it to everything on the inside of the parentheses. Why is this called a monomial?
Because it's so old. No, because it has
One term, yeah. And why is this a polynomial?
Because it has 4 terms.
No. Any of these are called polynomials, but what's the specific type of polynomial this is?
Oh, it's
How many terms?
2.
Which means it's a?
Binomial.
All right, here we go. So, we know we're going to multiply, right? So go ahead and multiply your coefficients. You get, so multiply them out. We're distributing. What's 5x times, so 10, and then our bases are the same, so it's going to be x to the, no. How many x's do I have? Don't forget your invisible 1. X to the
4.
Okay. Then I distribute my 5x to a positive x squared, which will equal
5x.
5.
To the third power.
Good. And that's your final answer. That's it. Now, it won't always be that case. The reason why I know this is my final answer, I don't have any like terms to combine. Okay? And I'm not even going to make I'm not even going to make you guys worry about twisting it around to put your powers in front. Well, this one's already in order anyway because the highest degree is first anyway. But down the road, you'll see what I'm talking about. Okay. Let's go. Let's work our way down. Again, I'm going to take my monomial and I'm going to distribute it to every term within my parentheses. So 5 times 2x squared is
7x squared.
Okay.
Plus.
Hold on. And then I distribute the 5 to the next term, and I get
5x.
Plus 5x. And then I distribute the 5 to the positive 4 and get
Positive 20.
Okay. Now I'm going to make sure my answer is in simplest form by looking to see, can I combine any like terms?
No.
Okay, done. That's it.
I would do the other one. Combine my terms.
Jesus.
Hulk.
All right, moving right along. I'm going to take my monomial right there, and I'm going to distribute it to every term on the inside of my parentheses. So I'm going to take 3y x to the 4th times 2y. What's that going to equal? I'll give you a hint. The first thing that I always do is multiply my coefficients. Then I worry about my variables. So I have 6. Let's put our variables in alphabetical order. So what comes next?
X.
Okay, so I have x to the what?
4th.
There's not, this 2y here doesn't have an x. So I just go ahead and bring down my x to the 4th. There's nothing to multiply those exponents to, okay? Now what about my y's? How many y's do I now have when I multiply, when I distribute?
2.
Y to the 2nd, good. All right. Then I distribute my 3y x to the 4th to my negative 5x squared. Again, my hint I always like to do first, multiply your coefficients. What does that equal?
How did you get 6x?
Because you multiply 3 and 2.
And then I put my variables in alphabetical order.
Okay.
Negative 15, okay. Now let's worry about alphabetical order. Let's worry about my x's first. So I have the same base, the same base. What does that equal?
3.
When I multiply exponents with the same base, what do I actually do with the exponents? Add them, so that equals 6. And what about my y?
1.
Yeah, just y to the 1. Now this is I'm gonna let you leave your answer like this. But if I would tell you to write your answer in standard form, this would be the correct order. Why not?
Is that a 12 or a 2? By the y.
2. Why wouldn't this answer be considered standard form? Don't we always start with the highest power?
Yep.
How many powers does my first one have?
4.
Plus 2 is,
6.
and how many does this one have?
6.
Huh? 6 plus 1 is
7.
7. Also, are these like terms?
No.
Why not?
Because they don't like the same variables.
They have the same variables, but they don't have the same exponents. Okay, final answer. Next, I follow the same rule. My number on the outside, I distribute it to each term on the inside. Do I have a coefficient to multiply with this time? Okay, so I just bring my negative 3 down. Okay, so then you worry about your exponents. So it's going to be x to the,
6th power?
no, because you multiplied them. When we multiply exponents, we actually
5th.
add, so 5th. And I distribute to my next, negative 3x squared times x, which equals x to the what? 3rd. That's right. Are there any questions on that? Or do you have a specific question? We feel pretty okay about this? For something new, do you feel okay? You feel down about it? Okay. If you feel down about it, and you don't click, it doesn't click with you at all by the end of the lesson, you know what to do, right? What are you supposed to do?
Ask you for help.
Ask me for help. Okay.
I never ask anyone for help, ever.
That will not serve you well in life. Okay. Binomial times binomial. Okay? So now I'm adding I'm throwing a little bit more at you here.
Yay.
So distribute each term of the binomial to everything inside the other binomial. This is where I would recommend using 2 colors. Okay? So what I'm going to do, I'm going to take this binomial here, and I'm going to distribute it to this binomial. So what that looks like, so I'm going to grab my red pen, and I'm going to first, so I'm taking this binomial right here, and I'm going to distribute it into this binomial. I'm going to do that by first focusing on the first term. So I'm going to take the 2x and I'm going to distribute it to the 3x. And I'm going to take the 2x and distribute it to the negative 2. So let's go ahead and, so we're kind of ignoring this positive 1 right now, okay? We're just focused on this 2x. So we're ignoring this. So what's 2x distributed to 3x?
6x.
6x what?
6x. Plus.
To the second power. Remember, don't forget your exponents. X to the 1 plus x to the 1. Okay? Then I'm going to distribute 2x minus 2 equals, what's 2 times negative 2?
Negative 4.
And then don't forget your variable. What's your x? Yeah, you got to take that x with it. Okay. So I did the first part of my problem. Now it's time, what else do I have to distribute?
The 1.
The 1. So I'm going to take the 1, and I'm going to distribute it to each term inside the binomial. So what's 1 times 3x?
3x.
Plus a positive 3x, right? And then I take a positive 1 times a negative 2 and get,
Negative 2x.
I don't see an x in there anywhere, do you?
Negative 2.
Negative 2. Okay. Now, my answer is not finished. I'm not done. Why?
Because you have to, like,
I have like terms here. What are my like terms?
negative 4x plus 3x.
Okay, so I still want my answer in standard form. So that means I'm going to bring down my 6x squared. And then I'm going to combine my like terms. What's negative 4x plus 3x?
Negative 1x.
Okay, instead of putting that negative 1x, what am I probably just going to put? A negative x, and then what?
Minus 2. Well, negative 2.
Yeah. And that's your final answer.
Even when I'm sick, I still work hard.
Okay, let's do it again. So distribute each term of the binomial to everything inside the other binomial. So I'm going to use 2 pen colors again. I'm a visual learner, you guys, so breaking things down into color, into parts, into steps really helps me. So which number am I going to use? Sam, I love you. Samantha, but you're not allowed to answer this one. You knew that was coming, didn't you? Which term or which number am I going to use to distribute first?
Negative.
Toby?
Negative 30x.
Okay, I'm going to use that, and I'm going to distribute it to everything in this binomial over here. Okay? When I go to distribute, the first thing I multiply together is your what? What do I multiply together first? Anybody besides me?
Negative 3x and negative 7.
So we're going to do our coefficients. So what's negative 3 times negative 7?
Negative 21.
What? 2 negatives equal a? Positive. Okay. Now we worry about our exponents. So do they have the same base?
Yes. What?
So do they have the same base? X to the third, x to the second? Yes. If they have the same base, Alec, and I'm multiplying, what do I do with my exponents? What do I do with my exponents when I'm multiplying and they have the same base? Don't listen to Ashley.
Yeah.
Jenna, help him.
And
Add. So when you add your exponents, what does that equal? I'm asking you, what does that equal? If you're taking x3 times x2 and you add the exponents, what does that equal? 5, yeah. Okay, so I distributed here. Now I distribute it to my second term. So negative 3x cubed times 2. Well, what's negative 3 times 2?
negative 6.
Okay, and then what's my variable?
X.
To the?
There.
And then you have to do the other one.
What do you mean by do the other one?
You have to do 4x
What am I going to do with that 4x?
and distribute to negative 7x
Oh.
squared.
And what does that equal?
Plus 2.
And what does that equal?
It would be negative 28 squared.
No, x to the
Oh, sorry, cubed.
cubed, and then what?
4 times 2 is 8
And then don't forget your variable.
plus 8x.
Okay. How did I get or how did it get, when he distributed this 4x times negative 7x squared, how did he get x cubed? Who can explain that to me? Raise your hand if you can explain that to me. Robert?
What?
How did I get that x cubed?
I didn't say anything.
Did he not raise his hand? He did.
No.
So,
Sure, yeah, he did.
look, when you multiply exponents, you actually do what to them?
Add.
Add. So what's 1 plus 2?
3. 5.
Right there is how I got it. Look, right here is how I got it, correct?
Yeah.
Okay.
Sure.
Okay. All right, flip your paper over. Moving right along. Now,
Trying to mess you up.
But we have
Yeah.
this, oh, Samantha, give yourself a +2. She does not have the Monday blues. She is on it. Samantha, what is the problem with this answer?
you have like terms to combine.
Yeah, I didn't combine my like terms. What are my like terms here?
Negative 6 to the third power.
But if I want it in standard form, what do I bring down first?
12 to the
I think you need to get sick more often.
Good.
Sam.
Then what?
and then you combine your like terms.
Which is?
I didn't already get that far.
Negative 6x and negative 20.
Negative 34 what?
X
And then I bring down my,
plus 8x.
there's my final answer. Good. How many degrees does this polynomial have?
Yee! Oh,
1, 2,
3.
9.
9 degrees. How many terms?
3.
So it's the 9th degree.
Trinomial.
Good. All right, now you can flip it over.
Sam, you need to
And we're going to do our last part.
Margaret wrote
Now,
You wrote what?
our last part, listen please. Our last part is the exact same steps that we've been doing. We're just distributing. The only difference is this time we're going to have a few more terms that we're going to use to distribute with. Okay? So it says distribute each term of the polynomial to everything inside the other polynomial. So whatever is out front, that's what we use to distribute. So how many times am I going to distribute this 3x squared?
3 times.
1, 2,
3 times.
3. Okay? How many times am I going to distribute this 2x?
3 times.
3 times.
1, 2, 3. So my first answer, how many terms is that going to have? If I distribute 3 and 3 more, how many terms is that going to give me? 6. Okay? All right. So this is where, again, I like to use pen colors to show where I'm distributing first. So I'm going to start with my 3x squared. I'm going to distribute that to everything inside my second polynomial. When I distribute, I like to first multiply my coefficients, then worry about my exponents. So Logan, 3x squared, I distribute it first to 4x squared. What does that
Negative
equal?
4. Oh, no, this 4.
Logan, not Nick. What's 3x squared times 4x squared? So multiply your coefficient, the number in front of the variable. Multiply that first. Do you know what I mean by coefficient? The number in front of the variables. So if you're using this number here to distribute, and you're distributing it to your first term here, what are the numbers in front of the variables? What's the number in front of the variable? And, okay, multiply those together. Okay, so you're still going to multiply your coefficients. Then you look at your exponents. You have your exponent and your exponent. Do they have the same basis?
Yes.
Okay, so when your exponents have the same basis and you're multiplying, what do you actually do with them, Logan? Okay, so add 2 plus 2. What do you get? Okay, so you have 12x to the 4th power. There you distributed the first one. Not done. Now you have to distribute to my second term. So you're going to repeat the same steps. So multiply your coefficients. So what are you multiplying together? And what? What's your coefficient? Okay, what's 3 times negative 4? Okay. Now we worry about our variables. So I have x squared and x. So do they have the same basis, the same variables? The ones you're using to distribute. Does this have the same base as this? Do they have the same variables? So how many exponents do they have then? If it's to the second and to the first, it's x to the, okay? You're not done yet. Because now we have to distribute to this last term. Okay, so we're using this exact same number and we're distributing to the last term of my polynomial. So multiply together your what first? Which is? And then what about your variable with exponents? What is this? To the x to the what power? Okay. Does this have an x? So is there anything I can combine it with? So if there's not, what do I do with it? I just bring it on down, right? Bring it on down. Okay. Oh my gosh, am I done yet? No, because what now? Now I'm going to distribute my 2x. So I'm going to take this 2x and I'm going to distribute it to everything inside this polynomial again. So, Alec, when I go to distribute my 2x times 4x squared, what is that going to equal?
8.
Okay. And then what about my x's? My exponents? X to the what?
Second.
Okay, but remember the invisibility rule? Anytime there's a variable by itself, what should you imagine that's there?
4.
A 1. So what's 1 plus 2?
3.
Okay. Now what do I distribute it to?
2.
X is going to be multiplied to what?
-4.
Which equals?
-8.
-8. Okay, now we worry about our variables. To what power is this? Oh, I forgot to do attendance. To what power is this?
X.
What power is this? An x by itself has what power? 1. Hello. Yes, he is on his way. Robert Emmerich. Okay, so look, yeah. X to the first, and this is an x by itself, so it's x to the...
1.
Yeah, if it helps, guys, put that 1 in there. So do they have the same base?
Yes.
If they have the same base, what do you do with your exponents? Add them. So it's going to be x to the what?
Second power.
Okay, one more. What am I going to distribute this to now? Okay, so 2x times 3 equals 6 what?
X.
Good. Okay, we're making some progress. Now what? What do you guys think I'm going to do next? Because you know this isn't my final answer. There's too much craziness up there for this to be my final answer. Samantha? Combine like terms. I want my answer in standard form, meaning I want to start with my highest power. So what's my highest power? Okay, do I have anything to combine that with? So I'm going to bring that on down. Okay, my next highest power.
3.
Somebody was like told me, but it was like a half yawn.
3.
Be more specific. I know what you're saying. I just want you to say it correctly. Show me.
I don't know how to show you. I just know that the next highest thing is 3.
So which is what? What are you looking at? Yeah, so what Lucas is doing here is he's looking at the exponent. The next highest exponent, he said, is the power of 3. So the term that goes with that exponent is negative 12x to the third. And what else? What else has the x to the third on it? The plus 8. Okay, so I'm going to take negative 12x to the third plus 8x to the third. So basically it's negative 12 plus 8, which equals?
Negative 4x.
Okay, so my exponent and variable stays the same. Bam, bam, done with that. Okay, the next highest power is
Negative 8x to the second.
can I combine that with anything?
No.
Nothing there to combine it with, so I bring it on down. Okay. Next step,
Combine 9x plus 6x.
which equals,
13x.
is this in simplest form?
Yeah.
Yeah, all your terms are combined. And if you notice how nice and neat that looks, look, it goes right down your exponents in order. 4, 3, 2, and then what? 1. All right. Let's take a look at our next one here.
2 minutes.
That's okay. Is that all we have?
Yeah.
Okay, well, we have 2 more, so we'll stop there.
Yay, time to